Hello everyone! Today we are going to see how gradient descent works. Here we have the x as an independent variable and y as a dependent variable. We are trying to predict y from x. From data we have collected, we see the y value for corresponding x. For example, for x 2.03, y value is 4.03. Now, tomorrow you get a new value for x, suppose 1.5. Can you predict from the following data what would be the most suitable guess for y based on the data you have already observed? For that purpose, we do a linear regression analysis. Here is the scatter plot of x and y. Our job is to find the line such that the total distance from the points is minimum. Here we have the red line, and length of the green line shows the distance between the line and the points. The sum of all the green lines should be the least possible. Here we have another fit line. This time we see that the total sum of the length of green line is certainly less than previous one. If this is the line with least sum of green line, then it is the line of best fit. Now we can easily predict the value for 1.5. Since y value for the line of best fit corresponding to x of 1.5 is 2.8, the predicted value of y is 2.8. Now you see that with best fit line, we can make prediction for any other values. Now the question is, how do we find the best fit line? This line has two parameters. One is slope of the line, second is the intersection at y. If we know the slope and intersection at y, we can easily draw the line of best fit. Here, the intersection is slightly above 0. The regression equation here would be yi equals wxi plus b, where w equals slope of the fit line, also known as weight. B equals intersection at y, also known as bias. To find the weight and bias, there are several methods. One of the popular method is the least square regression method. But today, we will use another method called gradient descent. For gradient descent, we start with some random guess for weight and bias. Then, using the gradient descent method, we slowly move toward optimal weight and bias. Do not worry at this point, because I am going to show everything step by step. After we have decided the random guess for weight and bias, we calculate the predicted y for all x. Now, we can calculate the loss for each prediction. Loss is the measure of the difference between the actual value of y and the predicted value of y. Then, the cost function will be estimated, which is the average sum of the squared difference between actual value of y and predicted value of y. Here, we see that the cost is the function of weight, w, and bias, b. Here, I show you the 3D plot, where we can see weight and bias as an axis perpendicular to each other and cost along the vertical axis. For various values of weight and bias, we can see the respective cost. For the same 3D plot, we can visualize only two axes, weight and cost. We have the cost function as given here. If we take the derivative of the cost function with respect to weight, this will give the slope of the curve at the given point for weight-cost axis. Similarly, for the same 3D plot, we can visualize two axes, bias and cost. If we take the derivative of the cost function with respect to bias, this will give the slope of the curve at the given point along the bias-cost axis. So we take the derivative of the cost function first with respect to weight. Similarly, we take the derivative of cost function with respect to bias. We will be calculating following two equations in the Google Sheet. So, we have x and y. We are trying to predict y from x. For that, we first start with random value for weight and bias. We take the initial value for weight as 0 and bias as 0. With these values of weight and bias, we calculate the equation which will give derivative of cost function with respect to weight and another equation which will give derivative of the cost function with respect to bias. For that, we first calculate y predicted, which is weight times x plus bias. So it will be is equal to B15 times A2 plus B16. We hit enter and get the result for y predicted. Now we will calculate the difference between observed y and predicted y. This is C2 minus B2. Hit enter and fill the rest of the cells. Now we square the difference between observed y and predicted y to calculate the loss. At the end, we have summed up the loss to calculate the total cost. Now we can calculate the first equation here, which gives us the derivative of cost function with respect to weight. This is equal to -2 times A2 times D2. Now summing up all this value and dividing by 10 will give us dc dw, which is derivative of the cost function with respect to weight. So this is 1/10 times sum of all numbers. Similarly, we calculate the next equation, which will give us the dc db, which is the derivative of the cost function with respect to bias. So this is equal to -2 times d2. Now, dc db is equal to 1 by 10 times the sum of all the number above. So now we have derivative of cost function with respect to bias. Now we move here where we have learning rate. A learning rate is used to move the weight and bias slowly toward the optimal weight and bias. We take the learning rate as 0.01 here. Here, we estimate the new weight, which is equal to old weight minus learning rate times dc/dw, which is derivative of the cost function with respect to weight. Similarly, new bias is equal to old bias minus learning rate times dc/db, which is derivative of the cost function with respect to bias. So we have calculated the new weight and bias. So with this new weight and bias, we go over whole process again. This will again create another new weight and bias. So our aim is repeating the same process many times, such that the weight and bias moves toward the optimal values. To run the cycle many times, we make use of the app script, which I have already coded. Here, we are just moving the newly calculated weight and bias to new cells, such that the whole process runs as many times as we want. Here, we are running the process for 400 times, so we get the weight and bias after 400 cycles. Let's also draw the scatter plot and a line for y predicted. We want to see how the fit line slowly moves such that the cost or error is minimized, and the line slowly emerges as the line of best fit. And then we run the script. We now see how weight and bias changes. We see that the weight and bias is moving toward optimal values because the line of fit is approximating the observed values. After 400 iterations, we see that weight is 1.78 and bias is 0.19. So for our initial x of 1.5, y is 1.78 times 1.78, and we add 0.19 as bias, resulting in 2.86, which is same as our initial guess. Thank you. Please like and subscribe.